Hello and welcome back to the ReFramework training. Now that we've covered the key mechanisms provided by the ReFramework, we want to focus on a powerful feature facilitated by the collaboration between the template and Orchestrator, namely the distribution of workload among multiple available robots. In this video, we'll see how to run the same process on two robots to distribute the workload, one on the local machine and one on a virtual machine. We'll also find out how to send the stop command from Orchestrator to smoothly terminate a job. Let's get started. We're already running the UI demo process on the local machine. We've started the execution from Studio. We also have one virtual machine prepared where we have a robot connected to Orchestrator and the UI demo application installed. Now, let's see how we can run the UI demo consumer on our local and one virtual machine at the same time. With the correct folder selected, namely REF UI demo, we navigate to Automations, stay on the Process tab, and select Start a Job. We have three important settings here. The process is executed under a specific user or robot account. We can control this by editing the user or the robot account setting. Specifying only the account results in Orchestrator dynamically allocating the machine. The process is executed on one of the host machines attached to the selected machine template. Specifying the template displays an additional Connected Machines option, allowing us to select a specific host machine from the pool of connected host machines. Specifying only the machine results in the Orchestrator dynamically allocating the user or the robot account. Specifying both the user and the machine means that the job launches on that very user-machine pair. The Allocate Dynamically option lets us set the number of times that we want to run the process. Dynamic allocation with no explicit user and machine selection allows us to execute a foreground process multiple times under the user and machine that becomes available first. Background processes get executed on any user, regardless of whether it's busy or not, as long as we have sufficient runtimes. For this demo, let's set the number of times that we want to execute the process to 1. Leave the user or the robot account and the machine options set to any, and click Start. We could have easily set the execute the process to 2 or 3 times, of course considering that we have the runtimes available. As we can see, we have one process running on the sandbox, starting from Orchestrator, and one process running locally, started from Studio. The two robots are processing different items in parallel, thus consuming the queue much faster. We can check this by monitoring our queue. In the meantime, there's one more thing that we'd like to cover. We've talked about the stop mechanism built into the framework in a previous video. Let's see it in action. Let's go back to Automations and select the Jobs section. When we have a job running that's been started from Orchestrator and which is based on the ReFramework template, we can use the stop command. Let's stop the job. As a best practice, it's better to stop a job than to kill it. This will send a signal to the robot telling it that the process should stop. Do you remember what activity checks for this signal and what state it's in? Looking at the green virtual machine, we can see that the process has stopped. For the stop command from Orchestrator to work, the should stop activity is required in the process workflow. This activity returns a Boolean that indicates if the stop button was clicked in Orchestrator. In the ReFramework template, the should stop activity is the first activity executed in the get transaction data state. This is because we want to perform the check before starting a new transaction. If the should stop variable holds the value true, then the then block will be executed. The information will be logged, and the nothing value will be assigned to the transaction item variable, thus triggering the transition to the end process state. Now, if we go back to the jobs in Orchestrator and select the View Logs action for the stopped job, we can see that stop process was requested. This will now result in a slower processing speed. Where can we check this? Here in the UI demo queue chart. This is how dynamic allocation influences the processing speed. When running only on the local machine, we processed around 17 transactions per minute. When running on local machine and one VM, we were processing around 26 transactions per minute. Great! With this, we conclude our demo on distributing the workload with the RE-framework and Orchestrator, along with our overview of the key features of the template. After having watched this video, do you think that you could answer a few key questions? What is the main benefit of concurrent queue consumption? How can we execute a job using multiple robots? What options do we have for setting up the dynamic allocation? How do we send the stop signal? What activities are executed after the stop signal is sent for a specific job? In the next series of videos, we'll focus on building a project using the RE-framework with Orchestrator queues. Thank you for watching, and until next time, happy automation!